All right, we call this section number 2 in the define phase, Six Sigma fundamentals. We're going to talk some of the basic blocking and tackling elements. So some things will be metrics, some will be philosophy, some will be some actual tools that you can use on your project. But again, some more background to get us in the right framework to move forward with executing a Six Sigma project. All right, so some of the topics that we're going to cover here, what is a process? We're going to cover at a very high level. As we move into measure phase, we'll get into some more detailed types of flowcharts and maps and the like. But we'll use it here in order to say, what's the process view? It gives people a way to ground themselves into what the improvement effort is going to be all about. We start to talk about voice of the customer and how to turn that into, well, how are we going to measure what the customer wants and how well we're able to execute against that. We're finally going to show you that little iceberg and all of the things above and below the waterline. And then finally, back to those metrics, those things like sigma quality level and DPUs and PPMs, and how we might calculate those and translate back and forth between them. So we talked in the last section that this course is very process focused, and so we say, well, why do we do that? Well, it helps us to understand and describe how work happens, and we can see how work moves through the business and works upstream with our supply base and downstream as we deliver things to our customers. Being able to see it, right, the picture's worth 1,000 words. So if we look at the flow, right, we really can understand what it is that is happening. And from a perspective of, right, it's not the people, it's the process. So as we see that the process is not efficient, the first level defense is, well, we must need more training. Let's go, right, get all the people in the world. Maybe we need higher skills. Let's make sure that the process itself gives us a chance to be successful. So we say down here, right, the definition, right, a repetitive and systematic series of steps or activities where inputs are modified, inputs are turned into outputs, right, to achieve a value-added output, right? So what are the steps where we take the inputs, do some value-added activities, and produce an output, right? One step above this, I always say a business is really just a series of processes or a group of processes that fit under one roof in order to meet a business objective. So that's why we look at it from a process. We're going to take inputs, add value to them, create outputs that we can sell to our customers. Well, I can tell you that as you go through, and especially after you finish this course, you'll certainly look at processes in a different way. And maybe we don't think of them that way, but hey, there's processes all around us, right? So, right here in Michigan, it's not so much paving roads as it is filling in potholes. The other day I had to change a tire, right? There's a process. You got to get the jack out. You got to put it in a certain place, right? Get the spare out. Don't do like they did on Christmas Story and lose the lug nuts. Opening a bank account, reconciling, right, your checkbook at the end of the month. So you have internal processes that you use in your life, and your business has processes that it uses to satisfy their customer. And so I can tell you that from this point forward, whenever you're standing in a queue, you're going to start to think about, well, what's the process and why is it causing a line to exist, and why does it take so long to get through the process? So it becomes a little bit of a curse that you'll see things from a process vision, and you'll always want to say, well, how could I make that process better? Okay, so here we're going to look at our first tool, a good old process map, or just a simple flow chart. And we use it in the beginning in the define phase to just talk about, well, what's the process that we're going to try to improve. And so we usually define, I call it the left and the right boundaries. We're going to have a start point. We're going to do some things that hopefully add value to our customer. And then we hand it off either to the customer themselves or to the next step in the process. So we use it to identify flow. It also can give us some feel for complexity. So how many steps does it have? We'll look later at doing process maps that have departments in them. How many different types of resources do we need? We can start to identify rework loops. So I'm going to look at the product here and say, okay, if it's good, it continues. If not, right, it goes back either to step A or step B to have further work done. So, again, very simple look. I really like it in this part where it defines my left and right boundary in terms of scoping what it is I'm going to work on. All right, it's important, and we'll talk about this many times, what's really happening, not how it's supposed to happen. And so therefore, hey, maybe your sponsor or your director used to work in that area, and they're going to write it down on a whiteboard or on the back of a napkin like my boss does. But that doesn't mean that's how it really happens today. So we always say, hey, go out, talk to the people that really work it, go out there yourself, and draw out how the process works today. And we're trying to stay at a very high level here, so we're not trying to get into the nitty-gritty details, but in general, what happens from start to finish, and what are the steps involved in the process we're going to improve. Right, there's some different tools out there. You may choose to go total ham on process flows. So there's Visio. I just typically use PowerPoint or Excel or something. SigmaFlow, iGraphics. There are all kinds of mapping tools available out there. We've gotten into some of the whiteboarding programs where you can just let everybody contribute to the overall flow. But don't make it too complicated. So in my years of experience, as soon as the 3M sticky note came out, hey, as a square or a rectangle, it's a work activity. Turn it 45 degrees, and it is a decision point. Connect it with arrows, and you have yourself a nice flow chart. You can add some different, more complex things as we go along. I do like to show the beginning and end as a green circle or ellipse to start, and a red one at the finish. If you need continuation onto different pages, you can say go to point 1, and to 2, and to 3 if it is going to flow over to a number of pages. But again, in the define phase, we're trying to stay high level. I always say 5 to 9 steps if you can summarize it in that fashion. Just to reiterate, in the define phase where we are starting out, our first step in DMAIC, we want that really high level map. Again, more as a communication tool. Hey, this is the process. It does start to define scope. So I always say, what's the left point? What's the right point? And our project has everything to do inside of here. So we're going to kind of ignore what happens upstream and downstream. Now this is our first pass at it, so we may expand if we need to. But this is our opening bid. So we want major steps. Eventually, we'll add more detail. What are some of the high-level decision points? And then, how does the flow go? And then are there any sort of rework loops where the product or the process goes backwards? So, we have a really high-level map. And again, we'll look to expand this as we continue to add more detail. So in order to kind of keep along with the different topics, we'd like for you to think about for the project that you're going to work, or maybe a project you've worked in the past, what was the high-level process map, right? What are the 4 or 5 steps that it took in order to define what the process, what's the left boundary, what's the right boundary. So take a few minutes and see if you can't draw sort of that high-level map, and save that, and then we're going to continue to build on that as we move forward. So stop the video here and take a few minutes to draw out that high-level process flow. All right, with that high-level process flow in hand, let's talk about customers, right? What are they saying? What is their voice? What do they need from our process? All right, so one of the first important questions, do we know our customers and do we know what they want? So one of the early things we want to develop and know to some extent, at least for our metric when we get to measure phase, is who are our customers? So do we know them? And what do they want? And one of the tricks is to take those voices, those verbatims, those things that they say that they want, and turn them into some type of a measurable quantity where we can prove as a business that we meet those requirements. So sometimes that's very simple translation, and other times it's going to take some work to go from that voice to how we will mutually agree that we've met that expectation. All right, so retouching on the last slide. Hey, it seems obvious. Hey, we make things or we provide services to satisfy customers, right? That's what we're in business for. So we must know what they want, right? Or do we? So there's been many a project in my career where solving some of the voice of the customer and refining their needs and their wants has gone a long way to solving their problems. So we can look at it some different aspects. Well, what things does the product or process have to provide? Right? What do they expect and need? How do we know we have the right list and the complete list? Right, from an integrity perspective, do customers trust that you will deliver things on time and to the correct quality level? So do we already have a nice established relationship with our customer base, and that they come to us because we have operational integrity to give them what they want consistently over time. Delivery. Well, do we meet our customers' time frame? So from order to delivery, are we hitting the mark? Right, and does the customer perceive us as providing value? So for all these, and these are just 4, and there can be a dozen. What is it that is important to the customer? And then how do we know that we're meeting their expectation? So this is the whole part of gathering that voice of the customer and trying to turn that into what is really critical to quality, critical to meeting their expectations. And so not all of these are perhaps equal, and the idea is we're going to come up with a hierarchical uh, list of customer expectations, what they want, and then how we are going to provide and satisfy what we call the wants and needs right of the customer. So to answer the first question, who are our customers? Um, right, we may or may not sort of know the whole breadth of who it is that we serve. So we can look at it in a couple different ways. There's a lot of different segmentation methods. We just talk about a few of them here. So these are always, especially in the auto industry where I work, but we have external customers, so we deliver to dealerships and to the customer that pays for a vehicle. But then we also have these government agencies. So, right, Department of Transportation tells you, right, what a tire must do, right? The EPA tells us how many miles per gallon and how many, right, units of carbon, right, a vehicle can produce. So when we look at a project, which of these customers are we trying to satisfy? So is it the person that pays the bills? Is it right a regulatory agency that we have to satisfy? Maybe both. And then if you're not the producer of the end item, right, you work someplace in this supply system, well, who do you deliver things to, right? So these could be internal customers. So it could be one department that hands off to the next. It could be one supplier that hands off to the next that's going to continue with the value-added activity till you finally get to the manufacturer that delivers something to the customer. So these are some easy ways to look at right, who might we try to satisfy. We can also look at big customers versus small customers from dollar value or volumes. And right, is this project trying to satisfy them all, or are we trying to look at a particular customer group that we feel might be underserved or unsatisfied with our performance? So any process that we try to improve is part of a bigger value chain, and we talk a lot about value-added activities in our processes. But if you look at any right very halfway complicated product, right, there's a chain of suppliers, and I call it kind of from dirt to product. So there's the very rawest of raw materials. And then we continue to add value. We continue to do assembly uh, processes until we finally deliver something to an external customer. And so part of the definition, part of scoping is, well, which part of the value chain am I going to work on? And then uh, focus there before, right, we would expand into to other parts of the chain. So sometimes a project might be at the interface, so it might be working with your upstream supplier together with your first steps in your process to make that flow smoothly. It might be at the end of your process where you're working with the next person in the value chain to make sure that what you deliver is what they need to further process things for their external customer. Or it might just be within your four walls. And right, we're going to define that with that very high level process flow. So it's important to know where we work in the value chain. We might eventually improve the value chain from beginning to end, but typically we're going to do it through a series of organized improvement efforts in order to make it go fast and for it to be successful. So what is a critical to quality characteristic? So these are those things that our customers expect from the delivered product or service, and it's our job to decide for this particular project which ones are we going to address. Hopefully, because currently our customer is not real happy with our delivery of one or more of these characteristics. So we have them broken down here. Again, this is hardly a complete list, but you can certainly think about a customer and how they might judge your output as being good or bad based on some of these factors. So on the product side, its performance, the different features, timeliness of getting an order to them. Hey, reliability. I work a lot in the reliability side of the business. Does it break? So serviceability, durability go together with that. Hey, you have a good reputation in the marketplace. On the service side, again, find the market. Are you responsive? So when the customer needs you, are you there? Reputation, credibility, going together. In some service industries, I work with Verizon. So hey, network security. Are you keeping people from stealing my data? The understanding, if you're providing services to the business, how well do you understand their business, and how are you making their business work better? So one or more of these different critical to quality characteristics are going to be somewhere in your project. And the key, as we'll show on the next slide, is, well, which one are we going to work on, and how are we going to measure where we are today, where we'd like to be, and then paint that gap in performance. So for addressing voice of the customer, we saw those three voices on our little chart in the last section, is part of the project objective, part of the business objective. We really need to look at these three steps. Who are the customers? So we can list them, we can segment them, we can prioritize them. Maybe we're working on, well, hey, if these three customers pay 80% of the bills, maybe we want those three customers to be the happiest. But which customer segment are we going after? So we start there. Well, what do they want? So we're going to look at those critical to quality characteristics, and hopefully determine one or two where we're not meeting expectations. So maybe we're not really good at timely delivery. Maybe we're not really good at a quality aspect or reliability aspect, and we can try to close that gap. And then mutually, in order for the customer to say that we did a good job, we should mutually understand, well, what's the measure of success? And if we're doing this on their behalf, would the customer agree that if we move this characteristic from this level to this level, that we in turn did get better? So they're not all created equal. We might prioritize one characteristic over another. And what we really want is how we're going to measure. What's the requirement? If it's speed to market, well, how fast is fast? And all of these move. So when I was originally looking at shipping things, it got shipped on time. Today with Amazon, maybe it needs to be shipped and delivered on the same day. So what is the requirement, so that we can make sure the process is designed to meet that. So confirmation that the customer nods their head, that if we could get to this performance level, that they would be happy. right? So the other side of the coin, not meeting a customer expectation has a cost, and or not meeting a business expectation or an employee expectation has a cost, and we call that cost of poor quality or COPQ. So let's look at a couple aspects of cost of poor quality, which will be the financial part or the business reason for uh, going forward with the project. And we'll measure our impact on this cost of poor quality both at the beginning and the end of the project. So it looks like I gave it all away on the last slide. So, right, just to look here, that's right. One of your jobs as right project lead will be right to estimate what the current cost of poor quality is. Right, this will be a driver for why the project exists and why it should move forward. And we will learn more as we go through the projects, especially in the measure phase. Is our calculation correct? So how big is our gap? We're going to know that when we get out of measure, and we'll be able to substantiate what the cost of poor quality is in the current state of the process. So COPQ is going to represent the financial opportunity, bigger financial opportunity, right? The higher the project's going to rise up on the list to be executed by right you as a project lead and the team of resources needed to execute that. Where do we start for right cost of poor quality? Some of the obvious. Well, hey, defects costs money. It may be hard to tell, right, the total cost, but we know some of the rework, scrap costs, those types of things. Some of the tougher ones are when I have an escaping defect and now I have a warranty cost or some customer dissatisfaction where I might lose that customer right over the fact that I had a defect. How do I prevent defects, right? So I'm going to do inspections and appraisals, and I'm going to have decision points. Well, those all cost money. So if I'm going to measure things, there's a cost for that measurement, and then there's a cost for making it go down a good path or a bad path uh, to be reworked. So those are some of the things that are kind of core from where did this come from, right, in the first place. The other thing we have on here is that, right, it's a symptom. It's not a defect itself, right? It's something we're going to try to quantify as the reason that our process is not optimum is because we have these costs due to quality not being what the customer expects. Right, so some of the more obvious, sometimes we call these the above the line costs. So scrap and rework, right? These appraisal costs, right? Some of my favorites in my old military days, inventory that we lock up in a cage, and then on Friday afternoons we decide what to do and disposition it. External, right? Warranty costs, right? How do we keep our customers happy? We send them a sales guy, we give them a discount, right? All of those types of things. And then, right, those all add up to, right, we have a whole uh, sort of department that does nothing but try to keep the customers happy. And if we could really be in this Six Sigma 3.4 defects per million, how much smaller might all of these things actually be? We're going to talk about how do we do prevention so that we don't have some of these costs. But right, mistake proofing, right, making sure our suppliers, right, we quantify that they're giving us what we want, designing in goodness into the product, and then right, how do we detect, right? So we do, right, send people to the suppliers, make sure that they're measuring things correctly. Oh, yeah, I used to do this. You don't want to get in that game, right? Sorting incoming parts. We're going to use these. We're going to send the other ones back. So these are typically what we call sort of the above the line costs that we can go out and usually pretty, um, you know, roundabout way quantify in some uh, respect. So it's definitely scrap, right? If we bought it for this much and we get this much in reclaim, right, we know what the actual cost of scrap is, right? If we have to uh, have a certain amount of inventory that is unavailable, right? We know how much right inventory is and how much it costs to carry that. I know, right, in part of my job, every week what we spend on warranty costs to pay for parts and labor to fix things. So we usually have a pretty good handle on some of the costs associated with these above the line type elements. All right, so here's our COPQ Iceberg. I've seen a lot of different versions of this over the years. But again, the ones we talked about on the last slide are the more obvious. But then there's right some of these that are a little less obvious, and I like some of these down here. Well, what if we used to call it in the telephone industry? What if a customer churns, right? They go they go buy their product from somebody else. Well, those are expensive. Right, when we took about look at the profitability of a single customer right over a lifetime, and you lose that, well, then you've lost all that buying into the future. And I can tell you in the telephone industry, we determined it was somewhere around customer acquisition cost was about 2 years worth of service. So you can imagine you pay your cell phone bill every month, right? Kind of giving away that for free just to get one more right customer right into the stable. Right, time value of money. I had some really good accountants over the years on some of my projects on. Well, hey, if you get the inventory down by this much, this is how much you're gonna save. Uh, Sometimes we know expediting costs, but I've worked in the aerospace industry where we've put jet engine parts in a first class seat and sent them to some airport someplace, right, in order to keep an airline going. Right, some rework costs in different departments. So maybe we need a change order in order to deliver something to a customer. So there's a lot of things both above and below the line, and one of your tasks is to think about in the process that you're going to go try to improve, which things do we know and not know, and maybe you can't quantify some of these, but you can at least talk to the fact that hey, if we don't get better here, right, we're going to lose customers. Right, we are going to have right overtime costs to meet customers' needs, etc., etc. All right, so some of the costs are more easily uh, quantified, right? We call those the more hard savings. We'll actually put that into the COPQ calculation. On the other side, I've seen it a few times if that's really the focus of the effort. But we can certainly talk to these things, right? Getting a customer for life, missed sales opportunities because we didn't either have the capacity or the quality level to right get to the next place, uh, right? Preventing regulatory right failures. So right if regulatory agency decides you're not meeting right the minimum requirements, well, hey, that's going to shut the whole system down until they're right satisfied again. So some of these right are game changers if you don't meet them. But typically when we talk about project cost savings, It's over here on the things that we can really quantify in dollars or hours or customer satisfaction levels. All right, so while the subject is fresh in your mind, hey, take a few minutes and identify cost of poor quality opportunities, right, either in your current right area of responsibility or for the project maybe that you've already been assigned to work through. So use the previous slides to help you. You know, look at the iceberg and some of the slides before that for the different categories, and just brainstorm a list of some of the COPQ opportunities that you think you could address by a current or a future project. So spend a few minutes on that. Go ahead and pause the recording, write a few things down, and then keep those with you. We're going to continue to build on your process flow and your COPQ opportunities as we build a charter and launch an actual project. All right, so pause the recording now and write down a few COPQ opportunities. All right, so now that you've got some COPQ opportunities in your mind, let's move into how we might measure things on a particular project. And we've already talked about sigma quality levels and yields, parts per million defective. So let's take a look at different aspects we might measure as process outputs. I've always liked these three dimensions for improvement, that you may work on one or all three at the same time. Some will say you can have any two out of the three, but not the third one. You got to pay for something. But I really believe that you can get and move all three in the better direction. So we talk about better, faster, cheaper. So on the better side, we talk about defects. So how are we failing to meet customer expectations? And some measures we have there are, let's count up the defects. So we can talk about defects per unit or defects per opportunity to make defects. So something normalized with the complexity of the product or process. And rolled throughput yield. So the whole idea of, if I have a string of Six Sigma processes, my yield to my customer is still going to be quite high. So these are some measures, one or all of which we might consider in the better or the defect column. In most transactional processes, we're looking for how fast can we do something. So how fast can I process that mortgage application? How fast can I get a quote out to my customer? So we're usually measuring things in terms of time. So what's the start of the stopwatch? When does the stopwatch get clicked off? Can I improve that time? And then finally, cheaper. Hey, that's all the COPQ stuff, right? So if I could get rid of those costs of poor quality, I can then fold that back into my profit margin for that particular product or service. So let's look at some definitions further for each of the categories. So in the faster category, I can use this on every project. How long does it take, so cycle time, to get to the end? So I start, I turn on the stopwatch, I do my activities, hopefully mostly value added, but there might be some rework in there. So how long does it take to get from beginning to the end? And I always want it faster. So that can always be a project activity. How do I decrease the time to get from the beginning to the end in the process? In the better category, I typically talk about defects. And we usually make a distinction here on how you're going to count the defects. If I'm going to count up all the defects, right, maybe I have different kinds of defects. I have scratches, I have pits, I have breaks. So I have a different number of categories. Then I'm just going to divide them by the number of things that I produce, the number of units. Right, we're talking in the defect per unit um, world. That's typically where we want to be because we can address all of those. If I don't have that breakdown and I just know whether or not I shipped it or I didn't ship it, right, as long as it has one defect, I am going to not ship it. So if it's either a 0 or a 1, we call that, right, it's defective or it's not defective. So we do differentiate between, I can count a whole bunch of different kinds of defects in a single unit, unit of production, or I simply just know whether it was good or bad at the end of the production line. I shipped it or I did not. And then our unit is always whatever the unit of measure is, usually the thing that we deliver to, right, the customer. So to show you, right, with a little block down here, if I'm measuring defectives, well, I just know that it had more than one defect. So this unit is defective. But if I go to defects per unit, yes, it's defective, but I know that it has 2 defects. And so I can say it has 2 defects per unit. So typically it's a little bit more granular. I can see more into not only that it's bad, but how many things are bad in that particular unit. Well, I hope not too many people are in this first time yield world anymore, but right in the past, it was always good if you started with 100 things and 100 things came out. And again, what we said was we usually lost the cost of poor quality because of all the different rework that might have happened along the way. But somehow, some way, we moved things inside the spec limits through further processing, through finessing, and we got 100 things out of the end. So here we're showing a golf club manufacturer, and what it's a very simple process where we've got your grips, your shafts, and then we attach the club head, and somehow, right, if they start with 100 units of input material, so 100 grips, 100 shafts, 100 club heads, they can get 100 out. But hey, along the way, we had to fix, right, 40 of the grips. We fixed 30 of the shafts, and we fixed, right, 20 of the club heads. Now, based on first time yield, 100 in equals 100 out. We're perfect. We're awesome, right? We didn't scrap anything. We didn't throw anything away. But our cost of poor quality is really down here. Well, how much did it take to, right, repair these particular grips? How much did it take to repair the shafts so they could be usable? What did it take to repair the club head to make the final club? So, right, the idea that I didn't scrap anything is not always the best way to look at performance. And I have an actual work example where I was working with a master cylinder manufacturer over in the west side of Michigan, near the lake, and it was a foundry, and I didn't know a whole lot about pouring metal and sand casts and all that kind of stuff at the time, but I walked in there, and in the middle of the factory there was this mountain of master cylinders, and I'm like, okay, well, this doesn't take a real consultant to figure out that's not good. And but I did. I went and talked to the plant manager, and they said, well, we just remelt them, so right, there's never anything that escapes from the plant, so all the metal in equals all the metal out, and therefore, right, I have 100% first time yield, so I'm really happy. And I said, okay, well, I got to take a different approach. So I went to the accounting team and I talked to the head guy that did the numbers for the plant, and I said, how much does it cost to get one of those like little master cylinder bodies to that point, right? Because we paid to melt it, we paid to cast it, uh, right, and then we threw it in that pile. And he finally came up and said, "Yeah, we figure it's about $6 of right labor that got put into that to get it to that state." Well, now it's a whole different story. So I've got a mountain times $6, right, which added it up to tens of thousands of dollars per month that right was happening over here. Yet if you looked at right, the plant had no scrap. So if you measure it this way, everything was great. Right? If you measured it the way I was looking at it, hey, we had a lot of rework that we were paying for that we needed to recapture into the process. All right. So in DMAIC, Six Sigma, my favorites, right, are this idea of rolled throughput yield, and the reason we have six in our Sigma quality level, right, is we want each step to have the highest yield possible. So if I look at it more from a what's the chance that I got a golf club out the other side without having to be touched with rework, we get a whole different story. So I have a 60% yield here at preparing my grips. I have a 70% chance of having right defect-free shafts, and I have an 80% chance of having right defect-free heads. Well, the chance that the club that was produced that never got touched with a rework cycle is what we call rolled throughput yield. So I'm going to measure the 60% times the 70% times the 80%, right, which turns out to be 34%. So in reality, and this is why we say this is a good, better type of statistic to use, is that my rework free units are only 34 out of 100. And so my opportunity then is right the opposite, right of that, or the 66 units that had to right have rework along the way. So we say this is a much better way to look at yield. I have a current project that I'm working on with parts deliveries, and right, you can see how the rolled throughput yield, right, we miss somewheres in the middle, right. So I go to my part delivery people, and they keep telling me when I push parts out into the system, I have a 90+% what they call fill rate. I get 92%, 90% of what I say I'm going to get right out into the supply chain. But then when I look at it from a repair perspective, and I need 4 parts to do a repair, and each one only has a 90% chance of success, right? 9 times 9 is 0.81, 0.81 times 0.81, 0.64. Right, I only have a 64% chance of making my customer happy that they're going to get all 4 of the parts that they need right at the same time. So, right, when I look at it from their perspective, hey, I'm great, I'm delivering 90%. When I look at it from my customer's perspective, we're not so good because they only get right 64% of the time get all their parts. So, right, we need to right bridge that gap of the idea of yield versus rolled throughput yield from a customer perspective. All right, finally, a little trick that we can use sometimes. We're going to show it in this example. You can mix and match DPUs and defectives when we have very low defect rates. And so in the top, we're going to show you that we can just add the defects per unit and switch over to yield. And that's a very handy, right? Doing addition is much easier than doing a multiplication of yields. So on the top one, we've got our defects per unit, right? The translation of the yield, right? We add them up, and we come up with 1/10 of a defect per unit. So a very low defect rate. And then we use one of our favorite equations. The yield is equal to e to the minus defects per unit. So e to the minus 0.1 is 90%. And lo and behold, I get the same answer adding up the DPUs as I do cross multiplying the yield. So 95 times 99 times 96 also gets me 90%. So when I'm in the low, right, whether this is defects per unit or right defectives, I can just add them up, use my little e to the minus DPU, right? It's EXP in Excel, or right, use the E function on your calculator. Right, it doesn't matter which way you do it, you'll get the same result. For higher defect levels, right, we always have to convert over to a yield, and we're going to show you that on the next slide. So, hey, in this case, it probably doesn't matter whether you say you have an 8% yield or a 3% yield. It's still terrible. But from a pure accuracy perspective, if I add up a half, 1, 2, I have 2.5 defects per unit. If I use my little e to the minus DPU, I get 8%. And right, versus if I cross multiply my yields, 60% times 36% times 13.5 gets me to 3. So if you're really in the small ones, you can add them together. If you have any doubt, it's always okay to cross multiply yields. So if I know the yield of this step is 95, this one's 99, this one's 96, right, this is always the correct way to do it. It's just that if I know them in DPUs, it's nice to add, just add them together. But why does it work sometimes and not others, right? And for completeness, right, we've got that on the next slide. Right, so usually we don't try to get too wonky with you. But for completeness, what's the difference between defects per unit and defectives? Well, they come from two different distributions. And so those that are familiar with the binomial distribution, right, it can have a pass or a fail. Right, bi means it only has two states. And so here we look at 90%, 78%, 61%, 37% yields. Well, it's right 9 goods, 10 bads. It's 78 goods, 22 bads. 61 goods, 39 bads. And right now we're starting to go the other direction. I got 63% bad ones and 37% good ones. On the other side of the coin, if I have defects per unit, it has a distribution that skews out to the right, where the DPU is actually the mean of the distribution. Now, for low levels, wow, those two distributions look the same. There's only this little sliver where I've actually got 2 defects per unit, and right at about the 10% range, it's not enough to make any difference. So you can see the two distributions right until you're hitting 20-25%, they really are giving you the same answer. So it would be inappropriate if I had one process that had 1 defect per unit, one process that had 3 defects per unit, another process that had 5 defects per unit, to try to make pretend that distribution looks like that one, because they really They really don't. And you can see that they start to deviate. So the bottom line is, hey, you can never go wrong if you cross multiply the yield of this step plus or times the yield of this step times the yield of that step. So you'll always get the right answer in that direction. Sometimes when you're doing a process mapping activity and you do have low defect rates, it's just kind of fun to just add them together rather than do the cross multiplication. So just know that the changeover point is somewhere in here where you have to have pretty low defects per unit in order for the two to match up. So here you got 75% yield, a quarter of a defect per unit, right? There's some small piece you can see here that's got 2 defects per unit where we only really allow 1. And then it really starts to deviate pretty quick after that. So just for completeness, right? Don't sweat it. But 2 different distributions: defects per unit, Poisson; defectives, Binomial. And we will further look at how we use the characteristics of those distributions when we get further into hypothesis testing. But here we're just looking for, hey, what's the yield of the overall process? And we don't want to look in terms of first time yield like we showed with the golf clubs, 100 in, 100 out. Right. So as we continue to venture into the defined phase and some of our background material, in this section we looked at a high-level process map. What's the left boundary? What's the right boundary? What are some high-level steps that turns my input into the output? Where am I going to get value for the project? Right, this whole idea of COPQ, cost of poor quality. Then we looked into, hey, am I going to measure faster, better, or cheaper? And some ways we might do that. The last couple slides got into the idea of defects per unit versus defectives. And then finally, the difference between this sort of nonsensical first-time yield, did I scrap anything or not, versus did I really get a defect-free unit all the way through my process. And then the body of knowledge elements that match these, I can now define a high-level process, talk about critical to quality characteristics, how those translate into cost of poor quality, and then these basic Six Sigma metrics are the ones we talk about over here.